I think of waste not as trash, but as a treasure. In the US, we waste a lot of things. We flush things down the toilet, we toss things out, and we don't think about it again. In a residential garbage, about a third of that is food waste and yard waste that we can turn directly into renewable energy through anaerobic digestion. About half of that waste is the plastics and the cardboard and the fibers that we can turn into renewable electricity through the thermochemical process. That means 3/4 of what you throw away could be renewable energy with the technologies that we have right now. We're taking something that is a wasted resource and turning it into something that we need, which is electricity, heat, and fuel. About 15% of all methane emissions come from what we throw away and get put into the landfills. And most of these emissions are from the food waste that's there. So today we're at the landfill, and you see trucks here that are depositing waste. What we do is really characterize this waste to understand, can we divert some of this waste to actually capture that energy before it gets to the landfill?
Today we came to collect samples. Every 3 months we come and pick around 500 pounds.
Sometimes there's really fun stuff in here. Bones, French fry. So this has bioenergy potential, but as you can see, actually, it is contaminated.
There is a lot of food waste, and by the time it gets here, it has already degraded, and it's very hard to separate out during the sorting process.
We have partners in Maryland, Virginia, Mississippi, and Ohio, Idaho, who are all collecting trash at different times throughout the year and at different locations, at schools and restaurants and businesses, at the landfill itself, so that we can understand this variability in waste characteristics over time, over place, and over location.
When we get onto the lab, we take a random sample, which we are going to sort into 27 categories. Out of the 27 categories, we are more interested in the organic material that is going to the landfill, the yard waste and the food waste, and then the plastics, the cardboard, the paper.
Anything that has the ability to degrade down, we can turn that into a renewable resource. In this project, we're using 2 different energy conversion pathways. So one is anaerobic digestion. So similar to what happens in your own stomach, where we have bacteria that breaks down our food. We're doing that in an external closed digester. And the bacteria that break it down produce methane. And we capture that methane and we use it directly for renewable electricity, renewable fuel, and renewable heat. But things that are harder to degrade by microorganisms, such as the cardboard and the fibers and the thin film plastics, we'll actually put those through a thermochemical process. We're heating something up under controlled conditions. So the gas that's produced actually has methane and hydrogen that we actually capture and again use for renewable electricity. We have collected 1 year of data on waste, and we're characterizing this waste in the lab, but then we're also characterizing the energy potential of each fraction of the waste. So whether we collect it from a school or from the landfill, how does that affect its renewable energy potential, and how much might it vary by time or by location? And this is providing interesting results to a government, to a municipality who's interested. I want to turn my food waste into energy, but I don't know what the potential might be. We'll be able to tell you, in the summer, this is what we got. In the winter, this is what we got. And if you're doing it from a school or from a restaurant, this is your expectation. we're already seeing interest throughout the country for really thinking of waste as a resource and understanding the steps to take it from waste going to a landfill to waste going to renewable energies. And in 10 years, I think we'll see a lot of these types of systems popping up throughout the country.